I know a lot of people will be excited when they hear the sonic boom.
And these are going to provide quite a show because you're going to hear those sonic booms.
Booster landing leg deployed.
That sonic boom is great for us.
That thunderclap broke the sound barrier.
Side booster separation confirmed.
Just heard the 2 sonic booms here in the room.
Booster landing confirmed.
There's a mystery out there in deep space, and solving it will make Earth safer.
Hello and welcome to the live coverage of the Hera planetary defense mission as it takes off from Earth and chases down an asteroid. I'm Matt Russell and I'm stood in the heart of the European Spacecraft Operations Centre, the main control room. We're really close to the first milestone, so I'm going to hand over to my co-host and legend and personal hero, Andrea Akamatsu. Take it away, Andrea.
Thanks, Matt. Welcome everybody to Mission Control. We have the spacecraft sitting on the launcher, and we are preparing for the final countdown here on our side. Flight Director Ignacio Tanco will start now the roll call.
Okay, on the stations. This is OD in the briefing loop. Upon my request, please respond with your call sign, followed by your status go or no go. OM.
OM go.
Some go. System 1.
System 1 go.
System 2.
System 2 go.
System 3.
System 3 go.
System 4.
System 4 go.
Flight Dynamics.
Flight Dynamics go.
Softcore.
Softcore go.
Software Support.
Software support go.
Project Rep. Project Support.
Project support go.
S-Track.
S-Track go.
Scheduling.
Scheduling go.
Okay, this concludes the roll call for Hera. ESOC is go for launch of the Hera mission.
We have just heard Flight Director Ignacio Tanco confirming with all the team leads of his team that ground segment mission control is ready for launch. This is the time where the flight director, acting as our orchestra director, makes sure that all the teams, all his players are ready to go. Each of them knows exactly what to do at any time in the sequence. Now let me check with him. Was it a good roll call? Everybody on the right loop this time, or the usual traditional screw up?
No, I think we got everybody on the right channel this time.
Good, already we start with a very good sign. All the best.
Thank you.
Back to you then.
Thank you so much, and absolutely thank you so much for allowing me to be in this hollowed hall for roll call. It was absolutely amazing. So this is the main control room. I won't be in here, so I'm going to have to leave. But before we leave, let's have just a quick look at some of the iconic flights that have come from here. Some of my favourites. Let's see if you can spot any of your own. I've got Giotto, Rosetta, Huygens, Venus Express, Juice, Euclid. Right, so I think that's probably about enough. I'm probably going to get kicked out. So I'm going to take you to my studio, which is down the corridor. We're coming from the Spacecraft Operations Centre for the whole day. So it's just down here. The Spacecraft Operations Centre isn't just a place where they control the spacecraft. It is also a watchtower for planetary defence, and we're going to be talking about that a lot, but it's about solar storms and asteroids and things like that. So I'm going to make my way to my little studio here in the dedicated control room, the astronomy dedicated control room, where they actually fly the spacecraft. So welcome to the astronomy control room. Behind me, you may actually see people coming in and out and controlling European Space Agency's fleet of space telescopes. It's a real working environment, so you might hear some alarms, Star Trek noises, bleeps throughout the show. So at various points, we will switch over to the live feed from SpaceX, and there it is. We can see Hera on the Cape, across the ocean. Pretty cloudy there. We're not just broadcasting from inside Mission Control either. Right outside, there's an exciting public event happening. We've got live music, activities, space fans of all ages gathering to celebrate this momentous occasion. Throughout the broadcast, we'll be covering some fascinating topics. We've got some amazing special guests joining us every step of the way, including an astronaut who will share their thoughts on space exploration, the incredible value of missions like Hera. Also be getting live updates from Andrea at critical phases during Hera's journey from launch to separation and that really important first signal. So stay with us as we take you through this incredible mission. So joining me now is Professor Alan Fitzsimmons, a key voice in asteroid research and planetary defence. Alan, it's absolutely great to have you on the show. You're going to be coming back, so I'm just going to have a real quick one with you here, where you're going to tell me how on earth did you even start to conceive of the Hera mission?
Well, it was 20 years ago that the European Space Agency put together a panel of experts, astronomers like myself and space scientists, to look at how ESA could really provide support to planetary defence. And the mission concept we focused on was a kinetic impactor, where you would use one spacecraft to hit a small asteroid at very high velocity and move it to a different trajectory, and then a second spacecraft would measure exactly the effects, so you could apply that lessons to other asteroids. And now today we have the NASA DART spacecraft, which has already successfully hit Dimorphos, and now we have Hera on the launch pad to go and make those vital measurements.
Yeah, so what kind of milestones are we looking for today for this mission?
Well, we want to get on off the launch pad, and we want to see that acquisition of signal at the end, where Hera calls home and says, "It's okay, I'm on my way to Dimorphos."
Yeah, it's no exaggeration, is it, to say that acquisition of signal is the key moment, isn't it?
Absolutely.
Well, thank you so much, Alan. It's been an absolute pleasure to talk to you. So obviously we're going to get you back later on in the show. So up next, we have a fascinating video that takes you behind the scenes of the Hera mission, from the initial planning stages to the international teamwork, a team of young, lean innovators that are required to get Hera off the ground. This video will give you an inside look at what it takes to make a planetary defence a reality.
"20 years ago, scientists didn't know what asteroids were. Actually, asteroids were not very popular in the science community, so we had very little knowledge about these bodies. There was a very interesting moment in history in 1994 when humankind saw almost live the impact of a comet on a planet called Jupiter. And that's when scientists realized that we could be next. The Hera project actually started almost 20 years ago. A proposal came from a professor called Milani, who proposed a mission called Don Quixote. And the idea was really to interact with the asteroid and trying to deflect it. So sending a spacecraft at very high velocity to impact it and change its orbit, its trajectory, and then sending a second spacecraft to study the outcome of the impact. So the Hera mission took a long time to get funding and being approved. But once it got approved, we only had 4 years to meet our launch window. And to do that, we really needed to do it in a completely different approach.
So in Hera, we work differently to the normal ESA project. The schedule is very compressed, so we have to work in a much more cooperation and close loop with the industry. So we are down to having tests done with equipment in the office to provide quick feedback and customer perspective on how things work. In Hera, we are using existing technology as much as possible, but some customization and new development are needed. An example is this radio system that starts from what has been developed for Proba 3 mission, where only 2 satellites are involved. So in Hera, we had to extend it to be able to handle the 3rd satellite, so having multiple links in parallel running, and to cope with much higher distances compared to the Proba 3. In Hera, we have 2 CubeSats and a mothercraft. The CubeSats are too small to have resources to be able to communicate directly to Earth, so they will rely on Hera to communicate at a short distance at the asteroid, and then Hera, with another powerful system, will communicate directly to Earth, and also the way back.
On board Hera, we have 2 CubeSats called Juventus and Milani. The CubeSat size is presented by this model. So you can see that it's quite small. It's, I would say, shoebox size. So Juventus has radar on board, so that will make first measurements from the distance of the surface of the asteroid. And that gives information to the scientist of the composition of the asteroid. Secondly, there will be images, so they will take images of the asteroid to have the surface, if it's rough, if it's smooth, what kind of a surface is on them.
ESA had a very specific knowledge in building fast and reliable spacecraft coming from the technology demonstration program and the program satellites, where ESA has worked hand in hand with industry to develop innovative and small satellites. By studying Didymos, the primary body, we can also understand how the moon was formed. The formation processes of these systems is still unknown today. So by studying the internal structure of these bodies, how Dimorphos has reacted to the impact, we can actually improve our knowledge of the formation of the solar system.
So now joining me is Paolo Martino, lead system engineer for the Hera mission. Welcome to the studio. So Hera's not just going on a journey to space today. The spacecraft has actually been absolutely everywhere, all round everywhere. So are you able to talk us through, I believe we've got a video of what's known as the launch campaign.
Yeah, that's correct. As Ian, Haley and Paolo were mentioning, Hera had to be developed at an astonishing high speed, only 4 years to develop a deep space mission. And so we had to take a series of tricks to save time. The spacecraft was built with 2 halves in parallel. This is not common, it's something typically do for telecommunication satellites. Half of it, the propulsion module, was built in Italy at the premises of Avio. The other half, the core module carrying the payloads and the avionics, was integrated in Bremen. Those 2 were mated in last summer, and that's where the spacecraft was born, we can say. And after that, we went to the traditional testing campaign. So we went to mechanical test to check that we could withstand the environment of the launch, thermal vacuum to check that we could actually survive the environment of space, a vacuum, extremely hot, extremely cold. And last but not least, which is one of the most interesting part, is the EMC, electromagnetic compatibility. So as mentioned, we are carrying 2 CubeSat, 2 small satellites that will communicate with the mothercraft via an inter-satellite link. This is because the CubeSat alone don't have enough power, don't have the voice strong enough to talk back to Earth. So Hera will communicate with them and will relay this information to ground, making use of its big 1.1 meter antenna and its powerful amplifiers. This is one of the first time that this kind of approach is used. We are really curious about that, and that was a very breathtaking moment of testing. After that, the spacecraft was packed, the solar wings were installed for one last time, and it was shipped to the US, where with an Antonov it landed on the shuttle landing facility already, a very emotional moment on its own.
Oh, I bet, I absolutely bet. And of course, now it's sitting on top of a Falcon 9. So thank you so much, Paolo. I know it means a lot to you and a lot of insights. I can see you holding in the emotions there. It's hard work all round, isn't it? And it's such a hard work to get a mission like this off the ground. So now let's turn our attention to the SpaceX Falcon 9 rocket, standing ready on the launch pad. This powerful vehicle is about to carry Hera on its journey into space, marking a really critical step in planetary defence. So let's take a closer look at the Falcon 9 as we gear up for launch. It's beautiful. Very good spacecraft. So let's shift our focus to why this mission is so important. Hera's destination, the Didymos asteroid system, and asteroids in general actually are key to understanding how we can protect Earth from these potential threats. So joining me now is Dora Foring, an expert in asteroid observation and planetary defence. Dora's been deeply involved in the efforts to track and understand near-Earth objects and works at the Near-Earth Object Coordination Centre, the main centre of planetary defence office of the European Space Agency. Welcome to the broadcast, Dora. First questions first. Give us a little bit of background of where the asteroids came from, what are they, and why are they so important when it comes to talking about planetary defence?
Yeah. So asteroids are the small rocky fragments that have been left over from the formation of the solar system. So they're made of the same material that the planets are, but they're just the little bits that haven't made it into the planets. We find most of them orbiting between the orbits of Mars and Jupiter, so slightly further out of the solar system. But they're very important to study because there's quite a large number of them that actually come much closer to the sun and hence the Earth. And these orbits then can occasionally intersect with that of the Earth and in fact hit us.
Yeah, so you work for the NEO Coordination Centre. What are the sort of, how do you kind of list your kind of priorities that you have there, the sort of pillars?
Okay, so the pillars of the NEO Coordination Centre, the first one that I'm working on is observation. So we're responsible partly for detecting and discovering new NEOs that we haven't seen before, but primarily to follow up objects, so refine their orbits, especially when there's been a new one discovered that we're not really sure of how its orbit actually looks like, to make sure that it's safe and that the orbit doesn't cross that of the Earth. But if there is something that looks like it could be on a collision course with the Earth, to keep refining the orbits and send more positions to the next pillar, which is the orbit determination pillar. So these are mathematicians, and we're constantly calculating and updating the orbits of all the known NEOs. And there's an interplay between the mathematicians and the astronomers, so they can send alerts if they see an object that looks like it's hitting the Earth, and then we can start observing that more rigorously. And then the final pillar is the mitigation, and this is what Hera is part of. So this is, if there is a threat, then what can we do about it? Partly how we communicate the threat without worrying people, but also collaborating with international organizations to launch these fantastic programs like Hera.
Yeah, I'm going to have to stop you there, Dora, because thanks so much for those insights. It turns out that SpaceX have opened up their feed earlier, so we're going to go over to the SpaceX feed now, slightly earlier.
Great.
Humanity can change the motion of an asteroid in space. DART collided into a small asteroid moonlet called Dimorphos, which orbits around a larger asteroid called Didymos.
Spacecraft is on internal power.
And that happened in September of 2022, about 11 million kilometers or 6.8 million miles from Earth. The collision shortened Dimorphos' orbit by 32 minutes, or about 26 times the predefined success threshold of 73 seconds. Hera will now return to the same binary asteroid system to survey the results of the kinetic impact up close and help researchers understand if it can become a repeatable technique among other mission objectives. Now, before we get into today's mission, here's a quick refresher on the DART mission, courtesy of NASA.
We're embarking on a new era of humankind.
Didymos and Dimorphos make a great target. We needed an asteroid with a moon that you can see from ground-based telescopes around the world.
We're doing this mission to prove that we can deflect an asteroid.
5, 4, 3, 2, 1. And liftoff of the Falcon 9 and DART on NASA's first planetary defense test to intentionally crash into an asteroid.
Even if we do everything right, our sensors work well, our spacecraft is doing well, even then, we might still miss.
4, 3, 2, 1. For the first time ever, humanity has changed the orbit of a planetary object.
NASA confirms that DART successfully changed the targeted asteroid's trajectory.
Using the ground-based telescopes around the world to watch the system and see how it's affected by this impact event.
This is a watershed moment for planetary defense and a watershed moment for humanity.
DART changed the orbit of a celestial body for the first time in human history, demonstrating one possible capability to defend Earth from a potential future impact. Hera will visit Dimorphos to measure its mass and makeup, as well as its shifted orbit from up close, performing its own crash scene investigation of the asteroid moon. The data gathered will help validate the DART-style deflection technique for operational use in case it's ever needed to help deflect any dangerous asteroids headed for Earth. Hera is the first planetary defense mission for ESA and will be the first mission ever to perform a subsurface radar survey of an asteroid using the smallest radar instrument ever flown in space. To help complete its mission, Hera is carrying 2 shoebox-sized CubeSats with it, one called Milani and the other called Juventus. Milani was named after the late Italian academic who devised the DART and Hera missions, and Juventus is the Roman name of the daughter of Hera. Hera will help pave the way for ESA's future interplanetary missions by testing deep space navigation and guidance and inter-satellite communication between the main Hera spacecraft and its CubeSats, which are packed with miniaturized technology and scientific payloads. The CubeSats will conduct proximity operations in the asteroid's extremely low gravity environment, flying lower and closer than Hera. And they will actually end their mission by landing on Dimorphos, which is 170 meters wide, or roughly the size of the Great Pyramid of Giza in Egypt. Hera is expected to arrive at Dimorphos in late 2026 to begin its 6-month investigation, delivering researchers on Earth critical data about future asteroid deflection missions and continue to grow our understanding of asteroid geophysics and build our knowledge about the formation and evolution of the solar system. With that primer, let's take a look at this video from ESA to dive deeper on today's mission and hear a special message from the ESA Director General.
There's a mystery out there in deep space, and solving it will make Earth safer. That's why the European Space Agency's Hera mission is taking shape, to go where one particular spacecraft has gone before. On the 26th of September 2022, at 6.1 kilometers per second, NASA's DART spacecraft crashed into the Dimorphos asteroid. Part of our solar system changed. The impact shrunk the orbit of the Great Pyramid-sized Dimorphos around its parent asteroid, the mountain-sized Didymos. It also sent a plume of debris thousands of kilometers across space. This grand experiment was performed to prove we could defend Earth against an incoming asteroid by striking it with a spacecraft to deflect it. DART succeeded, but that still leaves many things scientists don't know. What is the precise mass and makeup of Dimorphos? What did the impact do to the asteroid? How big is the crater left by DART's collision? Or has Dimorphos completely cracked apart, held together by its own weak gravity? That's why we're going back with ESA's Hera mission. But Hera is not going alone. It takes with it 2 briefcase-sized CubeSats to go in closer and take more risks than their parent spacecraft. And they'll end their duties by touching down on Dimorphos to gather extra data on its surface and gravity field. If a body of this size ever struck Earth, it could destroy a whole city.
I'm delighted you can join us today to watch the launch of the European Space Agency's Hera spacecraft on board a SpaceX Falcon 9 rocket. The risk of an asteroid hitting our planet affects everyone, everywhere, making planetary defense an inherently international endeavor. Hera is Europe's first planetary defense mission, which, together with NASA's DART mission, is part of the International Asteroid Impact and Deflection Assessment Collaboration. In 2022, DART demonstrated that humankind is capable of redirecting an asteroid. The mission to Dimorphos and Didymos hit the smaller body and changed its orbit around the larger asteroid. Now, ESA's Hera will visit this asteroid pair to investigate how DART affected Dimorphos. Hera will gather the data we need to turn kinetic impact into a well-understood and repeatable technique on which all of us may rely one day. My thanks go to everyone who worked so hard for so long to make Hera possible. Best wishes for a successful start of this epic journey.
Launching Hera today is Falcon 9, a two-stage rocket developed and manufactured by SpaceX, known for its safe, reliable, and cost-effective access to space. Starting at the top of the vehicle is the payload fairing, a protective shell that encases the payload being sent to space. That fairing will separate and jettison away from the vehicle, exposing the payload once Falcon 9 reaches space. And here you can see on your screen a photo of Hera being encapsulated in that fairing just a few days ago. The fairing halves that we are using today have supported multiple missions, one having flown 12 missions and the other 18. Now, continuing down the vehicle, we have the second stage. The second stage is powered by a single Merlin vacuum engine, or what we call the MVAC engine, which is optimized to perform in the vacuum of space. And below that is the first stage, which contains 8 engines arranged around one center engine held in place by a structure called the octaweb. Now, each of these Merlin 1D engines delivers about 190,000 pounds of thrust at sea level, which gives Falcon 9 a combined 1.7 million pounds of thrust. The booster supporting today's mission previously launched 22 missions, including Crew 1 and Crew 2, SXM-8, CRS-23, XP, Transporter 4 and 5, Global Star FM-15, ISS Aero C-3, Korea 425, Maxar-1, ASBM, and 10 Starlink missions. Now, due to the additional performance required to deliver today's payload to an interplanetary transfer orbit, this will be the 23rd and final launch for this booster, and recovery is not planned. However, we will be recovering the fairing halves. So with that, let's check in with John I for a status update on today's launch.
The launch vehicle and spacecraft are in good health. They're ready for launch as we are just beyond T-minus 9 minutes to liftoff. The Falcon 9 team reported on console at T-minus 2 hours and 15 minutes. They began their final checks of the launch vehicle and ground systems. We did a final checkout of the flight termination system. That was at T-minus 1 hour and 45 minutes. We then had the Falcon 9 team complete their data review of first and second stage propellant checkouts, as well as the avionics team and the guidance, nav, and control team. And they did all their final data reviews at T-minus 1 hour. At that point, the chief engineer conducted a technical readiness poll, and everything was go to continue. We've also completed at T-minus 38 minutes the poll to proceed with propellant load and launch. And most recently, you might have heard over the countdown net, the spacecraft has gone on internal power at T-minus 18 minutes and 30 seconds. Now, currently, the team at Cape Canaveral Space Force Station, they are loading propellant. That began on time at T-minus 35 minutes when our launch auto sequence began. We're loading 2 propellants on Falcon 9 today, a fuel and an oxidizer. Now, for Falcon 9, our fuel is a refined form of kerosene known as RP1. To burn that fuel, we need a source of oxygen, which we call the oxidizer. Now, most burning that you're familiar with on Earth uses oxygen that makes up about 21% of the air you breathe. But in space, there's no atmosphere to provide oxygen or other oxygen-bearing molecules, so rockets need to carry their own. Now, Falcon 9's oxidizer is super chilled liquid oxygen, what we call densified LOX. Now, the liquid oxygen is chilled well below its boiling point. That allows its density to be increased, and that in turn allows us to load more into the first and second stage LOX tanks. And that's an important advantage for missions like today's, where we need as much propellant as we can carry to get to the required interplanetary transfer orbit. Now, currently on the Falcon 9, you see on your screens, fuel loading is complete on the second stage. We're continuing on the first stage up until about T-minus 6 minutes when fuel loading will wrap up on that stage. And we are loading liquid oxygen onto both the first and second stages right now. In addition to its propellants, Falcon 9 also needs an ignition source to start burning that fuel and oxidizer. And for that, we use a liquid called TTEL.
Stage 1, RP1 load is complete.
And there we're on time. Fuel load on the first stage is complete. I mentioned TTEL. That's an acronym for a mouthful called triethyl aluminum and triethyl borane. Now, when we ignite the engines, we first flow liquid oxygen and T-tub into the gas generator in the main combustion chambers. The T-tub will burst into flames in the presence of the oxygen. So once we have that ignition, the RP-1 kerosene fuel is introduced and the Merlin engine goes to full power. And at liftoff, Falcon 9's 2 stages that you can see next to the strongback, they will combine to hold over 1.1 million pounds of the fuel and oxidizer propellants. Now, to provide maximum performance for the Hera mission, Booster 1061 will use all of its propellant. We won't save any for the landing of the first stage. On the weather front, you can see on the screen, it's cloudy, it's been a little rainy. We started the day with a 50% probability of violating launch weather constraints, but the good news is that the weather officer forecasts that we should be go 5 minutes from now. Mostly we've been watching thick clouds, make sure they're not too cold, where you might have triggered lightning. The good news is the clouds are warm, everything looks just pretty much gloomy, a little rainy.
Tanks are pressing
with
for
that,
strong back retract.
You hear the tanks are pressing, we're getting ready for strong back retract. So inside T-minus 5 minutes, all systems are go for launch from Space Launch Complex 40 in Florida. So Jesse, let's head back and watch the last of the countdown.
Thanks, John. It is T-minus 4 minutes and 38 seconds and counting. And as John mentioned, everything continues to look go for liftoff at T0. Now,
strong back retract has started.
Perfect timing. You heard that call out that strong back retract has begun. Now what's going to happen here is the clamp arms, which are just below the fairing, are going to open up, and once those are fully open, then that strong back, or what we call the TE, or transporter erector, will begin to retract away from the vehicle. And you can see on your screen that those clamp arms are opening up there. Now, the TE is designed to transport, raise, and support Falcon 9 at the launch pad using umbilicals or flexible lines to route the vehicle's fluids, power, and telemetry from the ground systems to the rocket and the payload until Falcon 9 switches to internal power and clears the pad. And you can see the clamp arms are now fully open, and that strong back, there you can see it on your screen, the TE is now moving slowly away from the vehicle. Now this is going to recline just a few degrees here, but at T0 it's going to move even further away, about 45 degrees away from the vehicle as Falcon 9 lifts off. And there you can see that the TE is pretty much fully reclined there on your screen.
Coming up on T-minus 3 minutes. Strongback is in the countdown configuration. It's about 1.5 degrees away from the Falcon 9. Waiting for next is completion of liquid oxygen loading on the first
Stage 1 LOX load is complete.
Right on time. So at this point in the countdown, the first and second stages are nearly fully loaded with the 1.1 million pounds of fuel and liquid oxygen. We have loaded all of the fuel on first and second stage. Liquid oxygen is now complete on the first stage. The last major event will be T-minus 2 minutes when we finish loading liquid oxygen on the second stage. And you can see right there the cold, chilled skin of the second stage. There's the warm Florida air moving by it. We're seeing the condensation of the moisture in the air. Everything continuing to look good as we come up on T-minus 2 minutes.
Stage 2 LOX load is complete.
And there's that call out that liquid oxygen loading is now complete on the second stage. Now that means that propellant loading is complete on Falcon 9. And that's over 1.1 million pounds of propellants now loaded on the vehicle. All systems remain go for launch. SpaceX ground computers are now draining propellant out of the lines that go up to the strong back onto the second stage. And there you can see that venting happening there on your screen. Now this creates a white cloud, which is pressure from the ultra-cold liquid oxygen line that's being vented there.
Front gas closeouts.
And again, when that cold liquid oxygen gas meets the warmer ambient air there, it creates that condensation that you can see there on your screen. The first and second stage computers on Falcon 9 will execute stored programs to prepare the rocket for flight, leading to the ignition of the M1D engines at T-minus 2 seconds and liftoff at T-minus 0.
Falcon 9 is in startup.
With that call out, the Falcon computers are running the final sequence for launch. First and second stage tanks are beginning final pressurization for launch. All systems are go. Let's listen in to terminal count.
LD, go for launch.
As Falcon 9 transports the European Space Agency's Hera spacecraft into space.
.30 seconds. Seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, engines full power, and liftoff. Go Hera, go Falcon, go SpaceX.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Slick 40. After clearing the tower, we begin to tilt or gimbal the engines. That initiates a roll maneuver you might see on the Stage 1 camera view, although it's kind of cloudy. But this enables the vehicle's antennas to stay in the best position for communicating with the ground. We are into throttle down now in preparation for max dynamic aero.
Falcon is supersonic.
Faster than a speeding bullet, we're supersonic on Falcon 9. Waiting for the call out from GNC of max Q.
Max Q.
Right on time. We're through the period of maximum pressure on the vehicle. The Merlin engines are back at power, and we're out of the throttle bucket. Now, from here on, even though the velocity is rapidly increasing, the atmospheric density is decreasing, and that's resulting on less loads on the Falcon 9. 90 seconds into flight, the rocket typically needs to go 17,500 miles per hour horizontally in order to avoid gravity pulling it back down to Earth and getting into orbit. We've heard the call out for MVAC chill. That's a bleed valve on the second stage engine. That's performing the final chill prior to second stage engine ignition. All's looking good with the first stage trajectory. We're coming up on T plus 2 minutes. Views from onboard the camera mounted on the inner stage of Booster 1061. Now we've got 3 events that'll be coming up in just under 30 seconds. Main engine cutoff, the 9 Merlin engines will be throttled down and shut down. Then we'll get stage separation and then startup of the MVAC engine on its first of 2 burns on the second stage. We've begun throttling down the Merlin engines.
Main engine cutoff.
Call for MECO.
Stage separation.
Successful stage separation.
MVAC ignition.
MVAC ignition and westbound power on stage 2. Coming up will be fairing deployment. And for the first stage, as we saw it in the background, farewell 1061, and we thank you. As we continue climbing out of Earth's atmosphere, we're waiting for the right time when we can open up and deploy the fairing. That should be coming up in about 10 seconds. There's a camera view as we switch. You can see Hera inside the 2 halves of the fairing.
Fairing separation.
and successful payload fairing separation. As we mentioned earlier, the fairing halves have supported multiple missions. One half has flown 12, now 13 missions, and the other had previously flown 18. And those fairing halves will come back down to Earth. They're guided by cold gas thrusters and then parachutes or parafoils.
Falcon is on a nominal trajectory.
They'll deploy and they'll be recovered by our recovery vessel, Doug. Jesse, T plus 4 minutes, 23 seconds. Everything continues to look good on Falcon 9 with Hera.
Thanks, John. Yeah, everything's looking great. We got some awesome views here on your screen. What you're looking at is a view of the MVAC engine on the second stage with a beautiful view of Earth in the background.
STS has safed.
Now, we are currently in the first of 2 planned MVAC burns for this spacecraft. And we have separated from the first stage. As we mentioned earlier, we will not be recovering the booster as we usually do. Now, typically we would land the booster either on a drone ship or back on land, but due to the additional performance required to deliver this payload to an interplanetary transfer orbit, we will be not recovering the booster today. Now what you are seeing, again, is the MVAC engine. The MVAC engine is optimized for the vacuum of space and has about 220,000 pounds of thrust in vacuum. Again, this is the first of 2 burns. The 2 burns for the MVAC engine will take the second stage with the payload attached to the targeted drop-off orbit.
Falcon continues to follow a nominal trajectory.
And great call out there, following a nominal trajectory. You can also follow along with the speed of the vehicle as well as the altitude in the bottom right hand corner of the screen. And the next event coming up in about a minute and a half from now is SECO 1. SECO 1 is second stage engine cutoff 1, which is where we will shut down that MVAC engine and allow the vehicle to coast with the payload in an Earth orbit, and then we'll reignite that MVAC engine for a second time to take the vehicle and payload to that interplanetary transfer orbit. Now we're just about a minute away from SECO 1. And you can see in the bottom right hand of your screen that the speed is continuing to pick up. The velocity is increasing on the vehicle as the MVAC engine continues to burn. But again, in about 40 seconds from now.
Stage 2 is in terminal guidance.
In about 35 seconds from now, we will shut down that MVAC engine and again allow the vehicle to coast in an Earth orbit before we make its way to the interplanetary transfer orbit.
Stage 2, STS has safed.
Continuing to get good callouts and some great views here. Again, this is from the second stage looking at the MVAC engine. The Hera payload is still attached.
MVAC shut down.
Nominal park orbit insertion.
And great news. We heard the callouts as well as saw that MVAC engine shut down, and we got a good confirmation of nominal orbital insertion. Now, the second stage is now embarking on the first portion of its coast phase. Coasting in this orbit will last about 45 minutes, and we will light that MVAC engine for a second time around T plus 52 minutes. So we're going to take a pause, and we'll see you back here at T plus 52 minutes for SES-2.
Well, welcome back. If you're just joining us, that was an amazing launch that we've just witnessed. The Falcon 9 lifting off from Cape Canaveral, a cloudy Cape Canaveral. So taking the Hera mission on its way. I am grinning ear to ear. There's a lot of happiness and jumping around in this studio. We're trying to keep it down because people are working, but there was very tense emotions in mission control as well. We had a lot of tears, and outside in the public event, people were jumping around and spilling their beers. So the excitement is building here in the studio in mission control. Let's take a moment to check in with the atmosphere is electric. Everyone cheers. The rocket is carrying off into space. It's an incredible moment. I'm going to take you over now to the main control room. Andrea, before we go for that critical acquisition of signal, can you introduce some of the incredible team? I know that they're probably a little bit the emotions are running high, but
sure. Yeah, thanks, Matt. Yeah, indeed, it was quite a moment here. The spacecraft is gone. But let's introduce a couple of people here in the control room. I have Richie next to me. Is one of our system engineers. Richie, it's been a while. You haven't been here in the temple of mission control. What's the feeling today?
I'm feeling quite overcome with emotion at the moment. It's been 10 years since I was here with Rosetta when we landed on a comet. It's been a long time working in mission development since then, so it's good to be back. Exciting to see the launch, and I'm just excited to get on with operating the spacecraft.
Excellent. Actually, get ready for the rest, and the best is to come. So I moved back here to Spacecraft Operations Manager Sylvain Lodiot. Sylvain, here we go. You wanted actually to move on to this mission after we finished Rosetta. Am I right in saying that this is a dream coming true finally?
Yes, it's correct. I mean, it was very difficult to say goodbye to Rosetta. There was then 4 amazing years on Solar Orbiter with an amazing team, very challenging. And now it's time to fly Hera. So it's also been very intense and amazing years with another amazing team. So it's time to fly, and many emotions today.
Yeah, I can imagine. Same for me. I moved further backwards here to Gabriela Ravera. She's one of the most experienced people in the room here. Gabriela, who have done supported several critical operations here from this room. What was special for this mission or for you?
Okay, shall I?
Please.
So basically, I mean, what makes it special for me is that you are not sitting next to us this time. So that's the first thing, of course. But talking to Hera in particular, it's the first time for me that I do a first acquisition with a non-S track station and with DSN in particular. So that's a big challenge for us, because it means that we will be communicating for Hera for the first time ever via our colleagues in DSN. We trust them a lot. We have been rehearsing and testing since almost a year now, which makes this moment very special. Also, if we are in the blind.
Good, thanks, Gabriela. Indeed, very important to underline this collaboration we have with the colleagues across the Atlantic. And this is all from the MCR. Back over to you, Matt.
Thank you, Andrea. I don't think there's anything more iconic as Andrea's smile. Good luck to all the incredible team in Mission Control as well as we await the all-important acquisition of signal. Wow, what an amazing day. As we continue our special coverage, I'm more than excited to introduce our next guest. It's Matthias Maurer, a European Space Agency astronaut who returned in 2022 from his Cosmic Kiss mission aboard the International Space Station. In fact, he rode on the exact same launch vehicle as we've just seen here at launch there. So, Matthias, it's an absolute honor to have you on the show. Welcome.
Well, thank you. The honor is all mine, and congratulations to the launch team. That was a fabulous launch.
Well, it was, wasn't it? Very exciting. Yeah. So obviously this is all about asteroids and planetary defense. So what significance do asteroids pose to people on the International Space Station and space exploration in general?
Well, the day the International Space Station would have an encounter with an asteroid would be a really bad day. But we astronauts, we also hope to fly further than the International Space Station. The next step will be the moon. And on the moon, we have lots of impact craters. And that's why we all also get training. And we go, for example, to the Nördlinger Ries, which is a massive impact crater here in Germany, where an object the size of 1 kilometer in diameter, so a tiny little bit larger than the object we're flying to right now, hit Earth 15 million years ago and left a massive crater of 25 kilometers in diameter. So this we don't want to see happen again, and that's why we fly this mission.
Yeah, so do you see human missions to astronauts contributing to the understanding of what we do to try and protect the planet?
Yes, definitely. So I think a mission like the one that we see today, Hera, that is better done by robotic mission because it flies out 2 years and there's a lot of radiation that an astronaut would get on such a mission out there. And it's a one-way mission. I don't want to fly a one-way mission.
Don't blame you.
Yeah. But I believe in the future we will learn so much, and already in 2029 we will have another asteroid flying very close by of planet Earth, so around 40,000 kilometers, so actually much closer than the moon. And this could be in reach of even a human mission if we are ready by that time. But I don't think we will have the technology in 2029. But let's think a little bit beyond the horizon. Such an asteroid may pose a threat to humanity once it impacts, but some of these asteroids actually are very precious. They contain a metal core of maybe even very precious metals, like the asteroid Psyche. And so I could well imagine somewhere in the future we will actually deflect such an asteroid to bring it closer to us so that we can mine it.
Yeah, so I mean, obviously it's very, very hard to get out to an asteroid, as you just explained. So would there be a real reason to send a human to do it rather than a robot?
Well, I think for the moment being not. So maybe you can send Bruce Willis. He already demonstrated his success in saving planet Earth. Yeah. But maybe in the future we will, I believe step one is we need to learn how to deflect such an asteroid, to deflect, to understand how such asteroids are built up. Just to get the basics ongoing, and maybe in the future we will have other purposes of flying to an asteroid.
Yeah, do you have a favourite asteroid? You mentioned Psyche earlier on.
Yeah, the Psyche one, it's like, I'm a material scientist, so I think flying to Psyche and getting the precious metal ore out, that could be also another childhood dream.
Yeah, it would be amazing. Do you have a favourite asteroid mission?
Well, I believe that one, Hera, is absolutely fantastic. I cross my fingers that we will see all the good scientific results flowing back, but also the mission following after, the one that probably the Ramses mission that we all talk about, to fly in 2029, to visit the asteroid that will fly by Earth in such a close distance. That will also be another step.
Yeah, so we've just seen Hera sat on top of a Falcon 9 and go through the exact same journey that you went through. So if Hera suddenly became conscious, like a Greek goddess, explain how that would have felt.
Well, I mean, it's like I wouldn't recommend Hera to go conscious. I think it should stay alert and awake and going straight on. But in our mission, we had a commander, and the commander had also like a lever to pull on in case something goes off nominal. So we could have ejected from the rocket and then have safely landed back on planet Earth. I think Hera doesn't have this option. No. Also, our booster landed back on planet Earth. Here we needed all the fuel, all the last drop of acceleration to bring Hera on a good mission to the encounter with the asteroids.
Yeah, so that booster's lost forever now.
I think it made a good history. It's an honourable end.
It's an honourable end for a booster indeed. Matthias, it's been an absolute genuine thrill to meet you and have you give us your special twist on the Hera mission. Thank you very much.
Thank you.
So, if you've just joined us, we're broadcasting from Europe's Spacecraft Operations Centre here in Darmstadt, Germany. We're following the launch of ESA's Hera mission, a planetary defence spacecraft. Today marks the beginning of an exciting mission to explore the Didymos asteroid system. Stay with us, we'll guide you through separation. Here's first call from space. While Hera makes its way towards separation, it's a perfect time to dive deeper into the topic of planetary defence, which is at the heart of this mission. So I'm delighted to be joined, I don't know what happened there, to be joined by two special guests who I've rushed on and rushed off poor old Matthias. I'm sorry. So I've got delighted to be joined by Romana Koffler, Programme Manager Officer at the United Nations for Outer Space Affairs, and Richard Moisel, Head of the Planetary Office here at ESA. Together they'll help us explore the global efforts to protect Earth from asteroid threats and the importance of the collaboration in planetary defence. Welcome to you both. So, Romana, first question to you. Planetary defence is a critical issue when it comes to asteroids especially. What are the main risks that we face from near-Earth objects, and how are these risks evaluated and monitored?
First of all, congratulations on the successful Hera launch. We're very happy.
Yeah.
And of course, planetary defense is important, and so is international collaboration in this regard. And our office, the United Nations Office for Outer Space Affairs, works with member states, space agencies, and of course, European Space Agency is an important partner on strengthening collaboration also against asteroids, so that we are prepared, because an asteroid impact does not concern only one country, it concerns more, it can concern more space agencies, and that's why we need to bring actors together to prepare for successful missions in case there would be an impact threat.
Yeah, so obviously this planetary defence requires a really strong international collaboration. So how do you at the United Nations coordinate people like European Space Agency and some of the other space agencies?
Yes, well, member states already in the 1990s tasked the Committee on the Peaceful Uses of Outer Space to strengthen collaboration. And based on that, the committee established two global mechanisms. One is the International Asteroid Warning Network, or IOWAN, which is chaired by NASA. And the other one is Space Mission Planning Advisory Group, or SAMEPAGE in short, which is chaired by European Space Agency. And they collaborate. The IOWAN network observes the skies and would inform the office in case there is a credible threat.
Yeah, so Richard, European Space Agency plays a key role in planetary defence. How is European Space Agency contributing to protecting the Earth from asteroids, I suppose, potential asteroid threats?
As was mentioned earlier, we are one of two agencies in the world which have all in one package, so to speak, a full planetary defense unit. We observe asteroids, we calculate their orbits up to 100 years in advance, and then if we find any threat within the next 100 years, we react to it and support international collaboration to mitigate any efforts. And in such a way we are doing a lot for the planetary defense community in carrying a part of the burden.
Yeah, so what are the sort of current projects that ESA's up to, and what are some of the ones that you're building towards?
Well, our biggest project so far just spectacularly got launched. But that's not where it stops. On the contrary, that's just the beginning. We have to close a lot of observational gaps, how we call it. The night sky needs to be scanned more often and more thoroughly, so we're building a full survey network of telescopes called the FlyEye network, where we scan the night sky every 2 nights completely. Also, we're launching a mission to the day side of Earth where we're completely blind. For example, Chelyabinsk, we couldn't have seen it coming. We are launching a dedicated space mission to spot things like these, and many more.
Yeah, that was a great day. Well, where did that come from? Yeah. So one of the most talked about asteroids that we've heard about already is Apophis, that's coming round in 2029. What's so special and significant about that asteroid?
I mean, Apophis is significant because it's going to approach the Earth at a safe distance, but it's a very unique opportunity because it will be visible across the globe in many places with the naked eye. Actually, I have a model here, my stress ball. So at the United Nations, we're working with member states to declare 2029 as an International Year of Asteroids and Planetary Defense. And we will invite public, schools, universities to collaborate, space agencies, so stay tuned.
Wow, yeah. I mean, I like the fact that you should be getting stressed by asteroids approaching, but yours is doing quite the opposite.
Exactly.
You're taking your responsibilities very seriously, protecting the Earth. So thank you, Romana, for shedding light on the global efforts, and thank you very much, Richard, for sharing European Space Agency's absolutely pivotal role. So thank you both very much. So now let's turn our attention to another key mission that laid the groundwork for Hera, NASA's DART mission. Hera builds on that success of NASA's DART mission, which was the first ever test of asteroid deflection. While DART demonstrated that we can nudge an asteroid, Hera will now study the aftermath of that impact, providing crucial data on the effect it had on the asteroid. This will help us refine planetary defense strategies in the future. So let's take a closer look at DART and its groundbreaking mission, literally.
A year ago today, the world watched as the DART spacecraft smashed into Moonlight asteroid Dimorphos with the goal of changing its orbit. This kinetic impactor test was NASA and the world's first planetary defense test. Our momentum didn't end with DART's collision. Here's what's happened in the last year. In the immediate moments after impact, telescopes from around the world captured a burst of bright light, and the Italian Space Agency's LICIA made its flyby. DART scientists were looking for the amount of ejecta, the plume of debris generated by the impact that would give Dimorphos an extra push. Turns out, it was a lot, ultimately moving Dimorphos more than the spacecraft itself. When the math was done, the orbit change was a whopping 33 minutes. While analysis is ongoing, knowing this crucial number confirms that a kinetic impactor is a viable solution and will help scientists calculate how far in advance future missions may need to deploy. The ejecta tail would eventually stretch to over 70,000 kilometers long, about 10,000 tons of debris, and is still visible when last observed over 9 months post-impact. This ejected material are not on a course to be a threat to the Earth, but tracking them provides a better understanding of this unique test. The stunning images sent down by the Draco camera before impact have gotten a helpful lighting boost from the reflection off of Didymos, what the team is calling Diddy Shine. Modeling work using these images have allowed the team to build out the precise geography of Dimorphos, including the exact collision site. This work will be supplemented in 2024 when the European Space Agency Hera launches. Hera and its CubeSats will arrive in 2026 and land on the asteroid system in 2027 and provide radar imaging that can tell us more about the impact and about Dimorphos itself. The more we know about Dimorphos's specific traits and makeup, the better that scientists can extrapolate how kinetic impactors can affect other asteroids that we may one day discover heading our way. DART was the first ever planetary defense test for the world. The lessons learned in the days and months since impact have put us in a better position than ever before to defend ourselves from potential asteroid collisions.
So that was a great overview of the DART mission and its groundbreaking achievements. Someone at the forefront of planetary defence is Lindley Johnson, and he's head of planetary defence, no less, at NASA. He was unable to join us in person today, as he's probably going to be at the Cape for the launch, but he has prepared a special video for us, and it explains DART's heritage and how the European Space Agency with the Hera mission is building on that legacy to take planetary defence to the next level. So let's take a look.
Hello, this is Lindley Johnson from NASA's Planetary Defense Coordination Office. We want to give our congratulations to the European Space Agency and the Hera project for a launch of the Hera mission to the asteroid system Didymos and its moon Dimorphos. The collaboration that NASA has had with ESA for this effort that we call the Asteroid Impact Deflection Assessment, or AIDA, goes back for over a decade, when discussions were had in the planetary defense conferences and the Near Earth Object Working Group under the United Nations Committee on Peaceful Uses of Outer Space of how international space agencies could collaborate together to demonstrate a viable response to an asteroid impact threat should it be discovered. So that led to the establishment, under the United Nations endorsement, of the International Asteroid Warning Network and the Space Mission Planning and Advisory Group. And in parallel, this AIDA collaboration between NASA and ESA for an ongoing demonstration of the kinetic impactor technique to deflect an asteroid in space. So it was agreed that NASA would develop the kinetic impactor, which was the double asteroid redirection test, or DART, that impacted the moon of Didymos, Dimorphos, back in 2022. And since the kinetic impactor could only observe the asteroid for a few moments prior to its high-velocity impact, we needed this observation spacecraft that has become the ESA Hera project to do a more detailed characterization of the asteroid system, its composition and characteristics, and understanding the effects and a more detailed examination of the effects of the impactor on the moon Dimorphos. So that is what the Hera mission will provide in more detail for the demonstration of the kinetic impactor and this collaboration that we've had between NASA and ESA for all these many years. So the launch of Hera is certainly an important milestone for this endeavor, but it is really the beginning of the real work for the Hera project team for the 2 years of flight to the Didymos system, and then going in orbit and then collecting all of this data that is important for the Hera science team to add to our knowledge that was collected by the DART investigation team. So again, congratulations on launch and bon voyage, Hera.
So thank you so much, Lindley, for your time and for that really insightful look into the NASA and ESA collaboration. Now, I'm actually really excited about this. What's really exciting about the Hera mission is that we're not just talking about one spacecraft, it's actually carrying three. Well, there's three. It's carrying two. Hera is carrying 2 CubeSats on board, each with its own specific mission to gather even more detailed data from the asteroid. To tell us more about these incredible mini spacecraft, let's take a moment to explore the world of CubeSats. So joining me now is Filippo Corradino, the Chief Technology Officer of Tyvak International, the company behind one of these innovative CubeSats that are on board the Hera mission. Filippo, welcome to this little studio of ours.
Thank you.
So we've just heard there that there was this impact crater and the Hera mission is there to kind of investigate what's happened to that asteroid. So why CubeSats? Why do we need CubeSats to help?
Sure, well, CubeSats are very small, the size of a shoebox, and they can be released, these 2 CubeSats, by Hera a few kilometers out from the asteroid. And their mission is to take more risk than Hera can by itself and get as close as possible to the asteroid and bring their instruments really where they can do the most. And in the end, actually even land on the asteroid, which would be a first for CubeSats. Ever.
Yeah, I mean it's always great to have a first on a mission, and that's certainly a pretty cool one.
Pretty cool, yeah.
It's a very good one. So each of the CubeSats on board Hera has its own unique mission.
Yes.
So can you tell us a little bit about each one and what they're designed to do?
Yes. Well, Juventus will look more at the structure of the objects. So it's got this radar, and by listening to the pings and echoes of the radio waves passing through the asteroid can tell us whether it's a solid chunk of rock or if it's a rubble pile, so many different rocks just held together by gravity. And once landed, can also measure the surface gravity with another instrument. While Milani is more of a little chemist, let's say, it will look at the composition of the asteroid. So we've got a camera with visible light and infrared light sensors, and can tell us if which minerals are on the surface, if there's water, how much of it. And we also have got a dust detector. We expect after the impact there will be a lot of dust in the environment, and we can measure how much of it is there, and what it's composed of.
Yeah, so the naming of the CubeSats. So at first glance you might think it's football related with Juventus and Milani. So, but I'm told that that's not the case.
No, it's just a coincidence, actually. So Juventus comes from mythology. It's the Roman name of one of the daughters of Hera, the goddess. While Milani is named after Professor Andrea Milani, who was the first astronomer who had this idea of the double mission with the spacecraft to impact on an asteroid to deflect it, and another one to go and run this crime scene investigation, check the aftermath, what's happened, and do the science.
Yeah, I mean, I really love the fact that it's Milani. It's such a fitting tribute to the man himself, whose idea that we're really kind of looking at. And I just love the fact that you're using CubeSats. It seems that CubeSats have sort of really opened up that space exploration to many more people and many more institutions.
Absolutely, yes. It's very, very nice, very interesting missions.
So, yeah. So the mission is full of firsts. So can you tell us, is there any sort of new technologies or groundbreaking technologies that are on these CubeSats?
Well, sure. For instance, on Milani, we had to develop a new thruster to move around the system, so a cold gas thruster, which needed to be very tiny because they're small, so they're packed full of equipment, and so we had to develop from another existing one a smaller, more compact raster, and it's got these little tiny jets, very, very tiny jets to move around, and many other innovations, navigation cameras, radios also, the link with the mothercraft, the intersatellite link. It's a new piece of equipment.
Yeah, so that was something we saw earlier on. Was that tested in that big room with the big
Yeah, that was the
triangles?
final test for the ISL, with all the spacecraft communicating with each other and with the ground in that moment.
Yeah, were you there at STEC when that
I was
test?
not. A colleague of mine that was there, yes, but it was very exciting. It was remotely dated.
As an old acoustician, that's one of my favourite rooms
Yeah,
I've ever been in.
It's huge.
It's such a good little space. So yeah, they talk to Hera and then Hera talks to Earth. Have I gotten that right?
Yes,
Yeah.
absolutely, yes. Because you cannot feed the radios you need to communicate directly with Earth on these tiny boxes.
Yeah, I mean, it's brilliant. It's brilliant. CubeSats going out into deep space and landing on asteroids. You couldn't make it up. So thank you so much, Filippo, for joining me. It's fascinating insight into the role of CubeSats these days in missions like this. So it's incredible to see how much innovation is packed in. So now just a quick reminder why we're all here today. This is a major moment in planetary defence as ESA's Hera mission builds on the legacy of DART, taking us one step closer to understanding how to protect the Earth from asteroid thefts. We're now checking out the SpaceX feed as the launch vehicle approaches its long coast phase. This is a critical part of the mission, with the vehicle cruising through space before the next major event. The team is closely monitoring everything as we move towards the next phase of Hera's journey. So now we've had a glimpse at the spacecraft progress, it's a great time to look ahead to the future of planetary defence. Here is just really the beginning. The follow-up mission will be Ramses, and that will build on the knowledge that Hera gathers this time round and push the boundaries even further. So I'm really pleased to bring back Paolo Martino, lead system engineer for the Hera mission, who will share more about both Hera and what we can expect from the exciting Ramses mission. So welcome, Paolo, once again.
Thank you.
How's your emotions?
Luckily, I had some minutes to recover because it was really a very emotional moment. I just ran out of tears. That's good.
You've run out of tears, right? That's fantastic. So, what do you expect to be Hera's legacy, and how will Ramses build on that legacy?
Yeah, in terms of planetary defense, Hera is just the beginning. We just come out of an outstanding fast development. We launched today even one day ahead of schedule, but that's the only way to meet asteroids. They don't wait for you.
No.
And now the next mission proposed to our member states in terms of planetary defense, the place to be in planetary defense is asteroid Apophis. In 2029, the night of Friday the 13th of April, we'll have a very close encounter with Earth. Actually, we'll be as close as roughly 30,000 kilometers, so we'll be even visible with naked eye from all Europe in that night. And it's so close that the gravity of the Earth is expected to have a strong effect on the asteroid. So on top of changing its orbit, will also change its rotation and possibly create material movings or landslides, earthquakes, really something unprecedented for an asteroid. It's really a great occasion to further improve our knowledge of these potentially dangerous objects. But the schedule is really, really challenging. We need to launch in April 2028, which is even faster than Hera. This is why we are working on this mission called the Ramses, Rapid Apophis Mission for Space Safety, which builds on the legacy of Hera and gets even more even faster, even more streamlined in order to basically be adapted to the different mission profile and manage to encounter the asteroid slight before its encounter with Earth and accompany it to this incredible moment.
So you've got your Hera team, and we've seen how much work, when you showed us the launch campaign, how much work to put that together, and of course the culmination of launch today, which is why you're very emotional. And you've been working late as well on the Ramses project. So how when you tell the team, we've got this new project and we've got to work even faster and harder, how does that go down?
The team is incredibly passionate and motivated. We all are. We really look forward to start prepare this new adventure and hopefully get the blessing at the end of next year. Most likely our families will not be as happy and motivated as we are, but I take the chance to thank all of them for their understanding.
Yeah, I mean, well, after all, you may be actually saving the planet. It's a good excuse. It's better than the excuse I have. So what have been really the major challenges with Hera and Ramses? Is it a sort of, there's no size fits all, that every time you build one of these spacecraft you've got to do something different?
That's correct. As a key also for future fast reconnaissance asteroid missions, which will be fundamental in the future for planetary defense to be able to assess threats. It's really not possible to have a one-size-fits-all, because asteroids are in very different places, very far away from the sun. Some can be closer. So you cannot really have an optimum design for everything. And every time you need to do some fine-tuning for the exact trajectory of that specific asteroid. Ramses is intended to be also a demonstration of how fast we can actually be in building an asteroid scout, a reconnaissance mission that in the future might help us to assess a potential threat and define whether it is actually a threat and we need to do something, or we can be more relaxed and just enjoy the show.
Yeah. Well, talking of enjoying the show, I'm going to let you go now, Paolo, because I know you want to kind of decompress, I'm sure, and take in the brilliance of this. So thank you so much, Paolo. So we have some time, I think, now to go over and see what's happening on the SpaceX feed. Of course, one of the hardest parts of this mission is designing how a spacecraft will actually get to its destination. One of the critical elements that's needed to be considered is the launch window, which we've actually hit today, the first launch window, and we've got it. A precise and narrow opportunity for the spacecraft to embark on its journey. Timing is everything. So joining me now is Pablo Munoz, a flight dynamic engineer, a key figure actually in the Hera mission, and one of the experts guiding its critical launch operations. Pablo, it's really great to have you here. So was there something really difficult about the Hera launch window? What was special about it?
Mm-hmm. So the very short answer would be Mars, but we can go step by step with the trajectory. So we launch when the Earth is at its closest point with the orbit of the asteroid, and about a few weeks later we perform the first deep space maneuver that targets an encounter with Mars. So we are very fortunate that for this launch window we have Mars at the right location at the right time, so that we can exploit its gravity to give us a kick and changing the spacecraft trajectory, and thus bringing huge fuel savings on the mission.
I think we've got on the screen behind us the actual orbital maneuvers.
So this animation is for the trajectory the planned trajectory we will be flying as of today. Mm-hmm. Here we go encounter Mars, which, by the way, will also take the opportunity to fly by one of its moons, Deimos. As said, the passing close by Mars gives us a gravitational kick. Then we perform another maneuver in deep space, which targets the encounter with the Didymos asteroid system. And then we start the rendezvous phase, in which we perform a sequence of braking maneuvers. As we approach the asteroid, we align the velocity of the spacecraft to one of the asteroids so that we can start the proximity operations.
Yeah, so if we'd missed today's launch window, you'd actually planned another one, which is completely different. So I think we can probably look at that one as well.
So yeah, this would be on the right side. So we have a backup trajectory for 2026. Now we know happily we don't need it. Had we had to use it, it would have two main drawbacks. One is that Mars would be at the wrong location, so we couldn't use its gravity. So this means we would have to spend much more fuel on the spacecraft side. The other one is, at launch, the offset in orbit phase between the Earth and the asteroid would be wider, meaning that it cannot catch up in a single orbital revolution around the Sun, so we'll have to spend 2 revolutions, which extends the transfer duration by a bit more than 2 years, which is the orbital period of the asteroid. meaning that we could start proximity operations in early 2031 instead of late 2026, which we hopefully will manage since we managed to launch.
Yeah, absolutely incredible. So it's a good job we did launch. Fantastic. I mean, it always amazes me the trajectories. I don't even know where you start or how you do it. Particularly, we'll just take in one of Mars's moons as well. Job done. So thank you so much, Pablo, for joining me. That's a great explanation. Before we take a short break, let's quickly check back in with Andrea, just meters away down there in the main control room here at Mission Control, for an update on how things are progressing as we approach the all-important separation. Andrea, how's it going in there?
Yeah, the mood is very high here. Actually, this fascinating launch liftoff time is just great for the team. The team are taking the last chance to have a sort of break, relax a bit. They've been working very, very hard next months. Liftoff, big emotions, but now the real stuff starts for them, and this is their last chance to take a short break for a few hours on. The tough part for mission controllers starts now in a few minutes, and this is what they're doing right now. But what is very good is the mood is very high, fully motivated, fully on the ball, and ready to go for the first signal from the spacecraft.
Thank you, Andrea. Just to remind everyone, you're watching ESA's live coverage of the Hera mission launch. We're taking a short break now as the SpaceX launch vehicle cruises for quite some time. But don't go anywhere. We've got more interviews, really brilliant interviews. And we've obviously got the really important part, the spacecraft separation. Hopefully we'll get some amazing shots of that. And of course, the all-important acquisition of signal coming up after the break. In the meantime, enjoy some fantastic and informative Hera cartoons, then the SpaceX feed right before second engine burn. So stay tuned. We'll be right back at about 6 p.m. CEST, or just about 1 hour after launch. So we'll see you then.
The incredible adventures of the Hera mission. Asteroid on collision course with Earth. Imagine the headlines. It may sound like science fiction, but to date we've discovered more than 20,000 asteroids whose orbits bring them dangerously close to Earth. It's a hazard the dinosaurs were powerless to stop. With all the advanced science and technology in our hands, could we do better? Planetary defense requires planetary cooperation. Meet the Hera mission, led by the European Space Agency, set to rendezvous with a binary asteroid system in 2026. Didymos is orbited by a smaller asteroid, Dimorphos. This pair poses us no risk, but our experiments with them will be key to keeping Earth safe. Dimorphos is a small asteroid, yet a rock of its size could devastate a small country or large metropolitan area. Studying asteroids like this from Earth is challenging. As a matter of fact, today we still know very little about their physical properties. The only way to capture their secrets is to go and visit, so we need Hera to get up close and personal. When Hera reaches it, Dimorphos will already have been impacted by NASA's Double Asteroid Redirection Test, or DART for short. This cosmic shove is expected to slightly shift the orbit of the asteroid moon. Hera will examine the crater left by DART, the composition of Dimorphos, map its surface temperature, and probe its internal structure, similarly to an X-ray. Meanwhile, Hera will deploy two briefcase-sized CubeSats called Juventus and Milani. Packed with high-tech equipment such as a low-frequency radar, a mineral mapper, dust analyzer, and a gravimeter, these mini-satellites will get an even closer look before attempting to land. Altogether, the DART impact and Hera's data will let us understand whether this technique can be used in the future to deflect an asteroid on a collision course with Earth, like an astronomical game of billiards. In addition to Hera's main planetary defense quest, the mission will gather invaluable bonus science. New understanding of collision physics and crater creation could revolutionize our understanding about how the solar system was formed. Hera will even test new techniques for autonomous deep space navigation and guidance, while working in the asteroid's extremely low gravity. This will help pave the way for future interplanetary missions. Not bad for a space probe the size of an office desk. Hera, defending Earth, one asteroid at a time. The incredible adventures of the Hera mission. In 1609, Italian astronomer Galileo Galilei became the first person to use a new invention, the telescope, to look at the moon. He was astounded to find strange circular features. Great minds of the time thought they could be volcanoes, glaciers, or even coral. Fast forward to the 20th century, and scientists had discovered many of these craters throughout our solar system, and even on Earth. They realized the craters must have been formed by explosive impacts. Space rocks smashing into moons and planets. Exciting. Studying craters became key for us to learn about the evolution of the solar system. They're like timestamps. The more craters, the older the surface. But there's only so much you can work out without knowing exactly what made a crater. So, we need to create a crater. For this quest, ESA's Hera asteroid detective is teaming up with NASA's DART, which is on a collision course with an asteroid called Dimorphos. DART aims to create the solar system's newest and perhaps most important crater. This time, we will know precisely the size, mass, and speed of the crater maker. DART will never actually see the crater it forms, so to unveil its secrets, Hera will take to the stage. Hera will take high-resolution images to chart its size and shape. The collision will blast out material from under the surface of Dimorphos, giving Hera a unique peek into what the asteroid is made of. Analysing this new timestamp will even help us work out how long ago Dimorphos was formed. Hera's discoveries will reveal more about the history and future of our solar system and help us learn how to deflect asteroids away from a collision course with Earth. It all starts with creating a crater. The incredible adventures of the Hera mission. Imagine you're going on a 2-year journey with no map, and once you arrive, you must conduct cutting-edge science using only what you have in your bag. That's exactly what Hera, ESA's asteroid detective, is going to do. To carry out her mission, she's packed with more gadgets than James Bond. Hera's target is the double asteroid Didymos, and in particular its small moon Dimorphos. The pair are 181 million kilometers away, but each measures just a few hundred meters across. To find Didymos, Hera will use an advanced camera to constantly scan the skies, looking for a single dot moving more than the others against the background of stars. Bingo! The same navigation camera will then be used for science, joining other high-tech kit, including a laser altimeter and thermal camera, mapping Dimorphos' shape, and discovering what it is made of. As it moves closer and closer to Dimorphos, Hera will be largely autonomous, like a self-driving car, tracking down a crater made by NASA's DART mission. Hera has 2 intrepid assistants, also packed with new tech.
The first burn placing Falcon 9 and the Hera spacecraft into the desired orbit about 3 minutes ago after launch. Now, we are approaching the second burn of the engine to carry Falcon 9 and Hera to the orbit needed to deploy the spacecraft. Now, coming up here in a few seconds should be...
And back ignition.
And right on time, SES-2. That call out was for second stage engine start. Now this burn is planned to last about a minute and a half. And we got a great view of that MVAC engine burning very bright there. Now during this time, we will be adding 4,500 kilometers per second to our velocity. And again, on the bottom right hand of your screen, you can see the speed increasing rapidly there, and you can also see the altitude of the vehicle and the payload. Now this is the second burn for this mission. There are 2 planned burns for this payload to be dropped into an interplanetary orbit. So that first burn took us into an Earth orbit, and now this second burn that's currently happening right now is taking the vehicle and the payload to that interplanetary orbit where the Hera spacecraft will be deployed. Now we're just about 30 seconds away from the conclusion of SES-2, which will be SECO-2, that second stage engine cutoff 2. And then we will shut down that MVAC engine, allow the vehicle to coast for a little bit prior to the deployment of the payload. Now SECO-2 is coming up here in just a few seconds.
MVAC shutdown.
We did have SECO-2, just waiting for confirmation of a good orbit. There you can see on your screen the MVAC engine has shut down. And the Hera payload there on your screen still attached to Falcon 9. If you're just now joining us, we did have 2 completed burns for that MVAC engine. Just about a minute ago, we had SECO-2 where that second stage engine did cut off, and you can see that there, no longer firing. And we do still have the Hera payload still attached to Falcon 9.
We were waiting to hear the guidance nav control officer call out a good burn. I think they may have been stepped on. We're looking at the data and we've heard the background chatter. We do have confirmation.
Nominal burn 2.
There we
Good
go.
orbit.
The chief engineer has confirmed we have a good second burn of the MVAC engine. So that means the Falcon 9 second stage, with the Hera payload still attached, has escaped Earth velocity. So we're no longer orbiting the Earth. We're now orbiting the sun. We've got one more major activity remaining in this launch mission, and that's the spacecraft deployment. You can see the Hera spacecraft right there, still attached to Falcon 9 second stage. That's expected to occur at T plus 1 hour and 16 minutes. So we've still got another 20 minutes, which means we're going to take a short break. And we'll see you back here at T plus 1 hour and 15 minutes for spacecraft deployment.
about it, Joel.
Yeah, we're trying out a new graphics configuration. Thanks all the way back to Kent, to Zoe and Austin and countless others who brought this one to life. The big ornate feather is gone, and the simpler graphics with the dark racetrack tunnels are here. One thing that we hope is that as the booster is used again and again, this simpler scheme will probably be a little bit more easily refreshed between missions. And a quick programming note about our webcast. We wish we could share our faces from the desk here today, but we're going to keep it simple. We're going to give you eyes on the rocket during the flight the whole time, and we'll be here on comms with you from the audio feed the whole way. So we got you. All right, let's talk about today's flight a bit more. We have some cool payloads on board today.
We have 12 on board today. In fact, all of them except for one are technology that we've developed right here in-house at Blue Origin.
At Blue, you know, we like to say we're building a road to space for the benefit of Earth, and that means we have a long roadmap ahead of us, a lot of future programs that we're going to be laying the groundwork for. We're going to be putting some technology tests into space today that will feed into several other programs that we have in the works. Very exciting.
So there are 5 payloads installed on the booster and 7 inside the crew capsule. And this includes tens of thousands of postcards on behalf of our foundation, Club for the Future, which is Blue Origin's STEAM-focused nonprofit. And if you didn't know, now you will. STEAM stands for Science, Technology, Engineering, the Arts, and Mathematics.
All right, so if you're just joining us, we're about T-minus 10 minutes from New Shepard's 27th mission. I do notice that we have just entered a hold. We will continue to track that as it goes. Now, this is the 27th mission for the program. It's also a brand new vehicle, as we've talked about. There's no crew on board today. And so we're going to be flying this test mission here. It's going to be a great day. So let's get into a little bit more about why we're doing this mission. As you know, New Shepard is a human flight program. We've sent 8 crewed flights to space and over 40 astronauts. It's really been amazing these last few years as we've built this program up.
New Shepard has done things that no other rocket has been able to do. So everyday people can visit space, and you've probably seen that on a few of our recent human flight broadcasts.
Yeah, this addition to our fleet is going to help us expand our capacity to fly more humans and really help to meet the ongoing customer demand.
And I can tell you, Joel, that really just seems to go up each and every time that we launch this rocket.
Awesome. So in a few moments here, we should be, provided we clear the hold, we're going to be going into a go, no-go poll. Let's toss it over to the rocket now as we await New Shepard and await this hold to clear.
All stations stand by for go full for terminal count. Let's say again, stand by for go full for terminal count.
All right, so welcome back, everybody. If you just joining us, this is NS-27, the 27th flight of New Shepard and a test flight of a brand new vehicle. We are here in a hold. We're about 3 minutes into the hold. We're hearing it should clear pretty soon. But while we're here in this hold, let's talk a little bit more about the importance of New Shepard as it relates to our long-term vision, and in particular, why we build reusable vehicles. So 99% of New Shepard's dry mass is reused, everything from the crew capsule and the booster to the engines and the parachutes. New Shepard's vehicles are currently designed for 25 missions, but really we're hoping to strive to quadruple that number over time.
We like to talk about the goal of operational reusability, or the idea that we can make operating a rocket more like operating an airplane in terms of how quickly it can be turned around and delivered for customer after each time that it flies. It's really exciting in the fact that we're adding a new vehicle to our fleet, so being able to reuse not but one, but two vehicles, we'll be able to turn the rocket around more often, more frequently, and make more humans astronauts.
The dream of reusability for space vehicles, it's really been around a long time, but the truth is that we really need to see a dramatic increase in the operational side, like you said, of reusability of our rockets in order to start seeing a truly radical reduction in the cost of access to space and to see that begin to happen.
Another key part is that we really talk about and emphasize the engines. The engines themselves, along with all of the other rocket components, must be designed from the ground up in order to be reusable. That means that engines can throttle, so that way you can fully control them, not just for vehicle ascent, but for descent and landing. So reusability, it's critical, and so is sustainability, which comes down to the sorts of fuel that we use in order to power our rockets.
That's right. So the fuel that we use to power New Shepard is also a great example of our sustainable approach. New Shepard's engine is fueled by a highly efficient combination of liquid oxygen and liquid hydrogen. During the flight, the only byproduct that you're going to see is water vapor.
Joel, I've just got to say that again because I don't think that's emphasized enough. The only byproduct of this outstanding rocket that we're looking at right here on the screen is water vapor. It's just sometimes hard to fathom. I had to say it again.
That's right, yeah. When we're watching New Shepard fly, I mean, I like to casually describe it as a steam engine, although I think the rocket engineers around me don't necessarily like that we call it a steam engine, but that's basically the byproduct, and it's really cool.
Well, look, I am all about various modes of transportation, and we all know about steam engines and how that played into automobiles, and it's really cool to think about it from that perspective, Joel, when we're looking at this rocket.
So reusability and sustainability, both so important at Blue Origin, and together these goals really help us to reduce the cost of space travel and to do it in a way that really reduces waste.
You know, when we're talking about sustainability and reusability, I think it just tips its hat to our overall long-term mission to have millions of people living and working in space. And when we do this step by step, when we do it with reusability and sustainability in mind, it really just, again, we're going in the right direction.
So let's take a moment now and check back in a New Shepard as we await for this whole
So, welcome back to our live coverage of ESA's Hera mission. If you've been following along, we've already witnessed an absolutely flawless liftoff, and now we're getting closer to a really key moment, spacecraft separation. The Hera mission is Europe's first planetary defence mission, and it's heading to the Didymos binary asteroid system to study how we can potentially deflect hazardous asteroids in the future. Hera's findings will help us better protect Earth from asteroids threats by building on the success of NASA's DART mission. Right now, we're at a critical stage of the spacecraft prepares to separate from SpaceX, making it all on our own. And soon after, we'll be waiting for that really important signal, the acquisition of signal, when Hera will call home. So before we reach that crucial point, let's check in with the main control room here at Mission Control. I know this phase is very tense and stressful and everything must go perfectly. So a huge amount is going on in Mission Control. Andrea, how's it going in there?
Welcome back to Mission Control. The mood is still very high, but the climate has changed here. Silence is dominating. Everybody back on console, focusing on the next step, going through the last checklist before this very critical phase. This is the time where we have evidence the spacecraft is alive in space, and it's exactly what we want to be ready for. So focused on that one, and talk to you in a few minutes.
Thank you so much, Andrea, and good luck. So, to get a signal from outer space requires deep space communication. So, a great moment, I think, to turn our attention to that topic right now. So, I'm delighted to introduce our next guest, Pamela Janinska, Ground Stations Operational Test and Validations Engineer at the European Space Agency here at ESOC. Pamela, thank you for joining us.
Thank you for having me. It was an incredible launch.
Oh, it was so exciting, wasn't it? I could see you beaming.
It was.
So yeah, I mean, deep space communication sounds fascinating, but I should imagine it's pretty complicated.
Yeah.
So tell us a little bit about it.
Yeah,
tell us about
Absolutely. Yeah, so every day our ground station networks communicates with deep space missions located hundreds of kilometers away from us. And we use massive antennas in order to send and receive radio signals, which you can think of them as like invisible beams of information traveling through space. And even though the spacecraft can be incredibly far away, our antennas are so sensitive that they can pick up on these signals. So you could think of this as like having a very long distance phone call, except the distances are so massive that it would take a while for the signals to reach us. So to ensure that the signals remain strong, we have to use massive antennas, such as the one in Cerbero, Spain, which is 35 meters wide.
Yeah, absolutely huge. So presumably that's not I mean, I guess they move a little bit, but not enough, because I'm just thinking that that's going to be stuck to the planet's going to be rotating, and then lo and behold, you've no longer got your little speck of dust floating out there in space, trapped in your beam. So how do you get around that?
Indeed, yeah. So our deep space stations are located around the world, and they provide 24/7 global coverage. And this is crucial because, as you mentioned, the Earth rotates. So this allows us to be in constant communication with the spacecraft, no matter how far away it is from us, and be able to continue to send commands and receive telemetry and science data, no matter how far the spacecraft is from us. And the really amazing part is that all of this happens remotely from right here at the European Space Operations Center in Darmstadt.
Yeah, and it's incredible. And we're actually in a room where some of that data actually comes in, and they're using it right now and talking to some of these absolutely incredible space telescopes out there, XMM Newton and things like that. I mean, it's amazing. We've actually got someone literally working there, and he's been really gracious letting us in here. So that's fantastic. So what in your view makes ESA's antennas special or unique?
Okay, that's a very cool question. So I think the most amazing part about these giant antennas is that they can talk, but they can also listen at the same time. But they don't just talk, they actually shout incredibly loudly because they're so powerful. And at the same time, they can really hear the faintest whispers from spacecraft coming from really deep in space.
So let's keep moving here. We're at T-minus about 6 minutes. New Shepard there on the pad awaiting launch. If you're just joining us, this is the 27th flight for the New Shepard program. I do want to mention that a lot of people, a lot of viewers might have today on their minds. It's a day of remembrance for many people. So we just want to thank our audience for joining us on a day like today. It's always exciting to go to space, but we always want to be cognizant of the other events going on in the world. So thank you for joining us today.
I'm really glad you called that out, Joel. And as we're looking at this beautiful rocket, we like to remember the fact that we are forging a path for a beautiful future, taking care of that next generation. So coming on with our wonderful postcards that we have on board today, we have postcards from Brunei and Pakistan, among many other countries. Thanks to NIAT, the satellite telecommunications provider in Brunei, for expanding the Postcards to Space program in Southeast Asia. A special thank you as well to World Space Week for your support in collecting those postcards from Pakistan.
All right, and Club for the Future also launched an online way very recently for students to draw digital postcards and send their art to space on New Shepard. So if you want to participate in this program, this is a great way to jump in. Anyone can do it. It's free. It's easy. It's super, super fun. I've done it. My kids have done it. I think you've done your own postcards to space as well.
I certainly have.
So if you want to participate in that, this one is always open. You can go to draw.clubforfuture.org. There's a really cool online app. It makes it really easy to do. And the tools online are just super, super fun and creative. So jump in and send your art to space. So with that, let's take just a quick moment here and check in on New Shepard and make sure that we are on track for our launch.
Inky blackness of space, we're ready to switch over to the SpaceX feed to witness this thrilling event live as Hera prepares to embark on the incredible mission to the Didymos asteroid system. Let's turn to the feed now.
Weather to cooperate. We had a successful ascent, stage separation. We've had the 2 burns of the second stage engine. We've got one more major milestone coming up to complete today's mission, which of course is the deployment of the Hera spacecraft from Falcon 9's second stage. That's going to happen just over 30 seconds from now. And you may have noticed when we shut down the engine at the end of the second burn, we were 204 kilometers, a little more than 120 miles above the Earth. If you look at the display on the bottom right of your screen, we've just crossed 7,400 kilometers as we continue to head out into deep space, as we have exceeded the velocity to escape from Earth. But right now, let's listen to hear the call out and watch for separation of Hera from the second stage.
Hera separation confirmed.
Great view. We've got successful deployment of the Hera spacecraft.
And with successful payload deployed, that brings our webcast to a close. Today's mission marks SpaceX's 389th overall mission to date and 94th mission of this year. Thank you to the European Space Agency for entrusting us with today's mission, as well as the range for their support. For continuing coverage of the mission, check out @ESA on X. And for continued updates on all of our missions, follow @SpaceX on X and spacex.com/launches. Thank you to all of our viewers for joining us this morning, and we'll see you again soon.
Got 2 people shouting at the screen because they didn't want to see, they wanted to carry on seeing Hera floating towards the Earth, or looking like it's floating towards the Earth, obviously going in completely the opposite direction. What an amazing shot that was. I think that's just incredible. Guys, you must be stoked. I can't stay with you too long because I've got to get over to Andrea.
Yes.
We're now moving towards acquisition of signal, which is when the spacecraft establishes communication with mission control for the first time. So let's check in with Andrea in mission control. Andrea, is it okay for you to talk to us through what's happening as the team prepares for this crucial update?
Yeah, welcome back once more from my side. The most nerve-wracking phase of the launch sequence has started here in mission control. And I would keep silent from now onwards because the colleagues have to focus on what they have to do.
Oh, no. Don't. Don't do that.
No, Michael is fired.
Good for him now. Okay.
I don't hear any.
It's moving.
Acquisition of signal over Goldstone.
We have just heard the flight director Ignacio Tanco confirming successful signal acquisition. This is the best news of the day. And then I let the team go through their checks now.
All stations, we have telemetry. Please proceed with operations.
Stand by for my door. We have low rates on the axis. Very command. Okay, we copy on the motor. Thank you. Yes. Yes. Yes, yes. We're no.
On the system one, I see rather inconsistent readings on the solar cells. I see only one with good voltage, say one, two,
The other stations, so beyond the briefing loop, we confirm acquisition of signal. We are now asserting control over the spacecraft, and mission operations is ready to start operations of the Hera mission.
Okay. So what an incredible day. It's just what we've witnessed, the successful launch of the Hera mission, seen the spacecraft separate in an absolutely beautiful view. We've seen that amazing moment, acquisition of the signal. What an exciting journey. It's the start of something really amazing. So you two, you've been right from the beginning. How are you feeling?
You go first. You me go first. Okay. Okay, so I admit I was wearing my lucky dinosaur socks, but I don't think that
mattered. Any superstitious things that you've done today, or in previous things?
Okay, now I get emotional again.
My mission is to make grown men cry. You know this.
Mission successful. So yeah, indeed, as you can imagine, after so many years, seeing the spacecraft grow at the launch site, last glimpse, we got to basically, I got to kiss goodbye to Hera and tell her, a safe trip.
Yeah, I mean,
don't forget to call home. And she did, and we were here to answer the phone.
Yeah, and she...
Proud dad.
Yeah, absolutely. I mean, it's just incredible, and you got to see one of the best bits of space video I've ever seen, I think.
Yeah, we'd like to say we planned that, but we're not sure.
It was absolutely incredible. So, you know, what does this mean to you and for the future of planetary defence?
Well, we're now going back. We're en route. It's a flawless launch, flawless communications. We've got a working spacecraft. We're now on the way back to Didymos and Dimorphos. We'll make those measurements, and we'll make the world a safer place from the impact of asteroids.
Guys, I'm going to let you decompress just for a second, and we're going to just quickly look back in the main control room where we can have a look at all those people working really hard. You know, I mean, talk about a roller coaster. When we look round and we could see some of those really stressed faces, and then suddenly it turns into absolute elation. So now I'm absolutely honoured to welcome Joseph Aschbacher, the Director General of the European Space Agency, to the set. Joseph, what a pleasure to have you in this little in the astronomy dedicated control room. Thanks very much for joining us. So with this successful launch, it's yet another success for ESA. What does this mean for planetary defence and the European Space Agency in general?
I mean, this is such an amazing feeling. I've just been watching these adult men crying and tears running down. I mean, this is just something so special. And no, really, it is fantastic. So we have a mission. This is really amazing. This has been put together in very short time, as we all know, and a lot of stress has been on the teams, on the science teams, on the project team. Really hello to all the project teams over there in the Kennedy Space Center, but also in ESTEC, here in ESOC and across ESA. Thank you for what you have done. This is an amazing job. But also thank you to industry. Industry, you have been working hand in hand with our people. And these have been two just wonderful teams, the industry team on one side and the ESA team on the other side. And this has really been a prime example for me also of new space at work, where we deliver a major spacecraft, almost 1.1 tons of spacecraft, 12 instruments, and really so sophisticated, but in a very short period of time. So really big thank you. But also my member states. We have, of course, we are sitting here in Germany, but Germany also is the biggest contributor to the Hera mission, and the lead contractor also is OHB from Germany. So without all the political support, without all the funding, obviously, but also all the support given by the member states, by the industry team, by our own teams from ESA, this would not be possible. And not to forget also our international partners. Thank you to NASA. NASA, you have shown us the way with the DART mission. You're also very strongly engaged in the science part of the evaluation that will come. And also JAXA, who has contributed an instrument, and I really appreciate this very strong support. So for me, it's an amazing day. It's just wonderful to see that. It's one more example, if I may, where ESA delivers. We have been actually quite a few successes this year, from Ariane 6 to EarthCare and Galileo and Sentinel missions and Vega firing, which we just had, the last Vega mission, and more to come. So yes, this is ESA at its best. We deliver success for Europe. In this case, we deliver success for humankind, because this mission is part of planetary defense, and this is our contribution of ESA to humanity to help us in the future protect our planet.
Thank you so much. Thank you so much. I mean, it obviously means an absolute great deal. Thank you so much.
Thank you,
right,
Matthew.
We've just got a chance now to have a quick look back in the mission control room, where the energy is high, and I guess the teams will be working extremely hard. Hopefully, Andrea will have made his way back, because I really want to congratulate him. So when he gets back, we will have this final conversation and have a little chat about what happens next, the really important part of the launch and early orbit phase, or LEOP, one of the most challenging parts of any space mission, crucial for ensuring the spacecraft is operating smoothly after separation, as the team work tirelessly to ensure that everything is on track as Hera begins its journey through space. So I'm thrilled to be joined by two very, very happy men, Paolo and Andrea, fresh from the main control room. I'm going to let them hug. I mean, these.
That was quite a ride.
So Paolo's been describing his feelings, but I'm not going to let you off the hook. And Andrea, how does it feel?
Well, I started working on this kind of mission years ago with Jan Carnelli. It was quite an adventure. I mean, we had to go through several obstacles. Embarking on something like this is not easy at all. It's not the typical approach the agency takes, and I'm super happy that the agency has made this step, and finally we have proof of success. There are lessons learned for sure, but we will learn a lot from this experience, and I'm sure it will be keep the agency with something new.
Amazing. So this is a sort of transition period, isn't it, that you're handing over from operations and to mission. So I've got the two people here. So yeah, try and describe what that's like, and maybe some of the emotions involved with that.
Well, it's very difficult to describe. First of all, the mission is just started, so now everybody is excited to see the morphos and see what happened there. But this will be left to the team of operation and also to all the scientific community that will take maximum advantage of the information that Hera will manage to gather. Personally, the project team, instead, after handing over the satellites to the operations team, will immediately move to the next adventure, say after maybe a small deserved celebration. But I was telling you before about the next planetary defense proposed mission, which is Ramses. So starting tomorrow, the team will start to...
Give them a break. No, you've got to get straight on.
It's too good. We really...
momentum.
we really can't help by keep on with the passion on this kind of missions, and we will start full steam on an even more challenging step, and hopefully we will make it another success story for us in the future.
Yeah, and I guess I mean, just seeing it, it's like the passion, I suppose, is what gets us here. I mean, it's really amazing. Thank you so much, Paolo. Now, Andrea, this is your last mission.
Yes.
And so, yeah, I mean, you're an iconic face in mission control. I mean, you know, over the years we've seen you in there. You're almost, you know, you're pretty famous. And this is your last mission. So how's that feeling?
Well, it's a bit mixed feeling. On one side, there's nice to be in the control room. I was missing a bit the action, to be honest. I would have liked being there, pressing a few buttons. I think what is very nice is actually to see a new generation of mission controllers having grown up to the level that they can take over this completely. And I think this is what makes me most proud of what I've done here. And it's the last mission. It's not the end of my career, but it's the end of my career here in ESA. And I'll keep flying high.
So we'll be able to see some of these things happening. As you can tell, right now the vehicle is breathing. It's on the pad. You can see the close-up views here. I love seeing these close-up views of the rocket, by the way. Getting up close to the rocket, especially with this new rocket, Isabella, the brand new livery. It's shiny white. One of the things that I think we expect to happen over time is that we refly these vehicles over and over, so they do wear over time, and you can see that visible wear if you were to compare this rocket to the last vehicle that we've been flying that's had several flights now, I think 11 flights on the other vehicle, and that's, you know, it gets darker over time and it starts showing the marks of reusability.
That's right, you know, but I feel like the wear, that's what gives it character. That's what shows that it's been to space, it's been on an incredible journey, and that it's ready to go again.
Yeah, that's right. So any second now, we're about 2 minutes and 10 seconds on the clock, and this is where we're going to start seeing some of those bit checks happening that help maneuver some of these and test the surfaces, the control surfaces that are going to make reusability actually possible.
That's right. And, you know, as our rocket here gets ready to do some of its final checks, I'd just like to remind everyone that we do not have astronauts on board today, but now is certainly that countdown time when they start to do their own checks for mindfulness and awareness that they are really about to launch, go to space, cross that Kármán line, come back to planet Earth, and be internationally recognized as astronauts.
That's right. So you just saw the bridge, the astronaut bridge has been retracted. We've entered our auto sequence, and this is where the automation of the mission really begins to take over, which is really exciting. It means we're very, very close. And you can see there's the fin movement. You can see the fins moving at the base of the rocket. These fins, they help steer the vehicle on both ascent and descent to give it full control. All right, we've entered another hold here with about 1 minute left on the clock. We're very, very close. The team is just doing, this is the first time we're flying this vehicle, so I think they're able to you know, get the readings off of the vehicle for the first time, and they're learning the nuances of every vehicle is a little bit different. So let's wait as Mission Control does their final verifications here and clears this hold. All right, so you've seen we've entered a hold here. I think we have just a little bit of time to let Mission Control here troubleshoot and get us ready for flight. So with that, let's take a minute and talk about the New Shepard experience. You know, the growth of the New Shepard program has been really just inspiring to watch, especially as an employee. We get to see all these great astronauts taking part in the experience and experiencing what it's like to come to West Texas, to meet each other, to bond together, and to really kind of make history together. So they've really, I think New Shepard has, really made just an incredible impact on the spaceflight community and in such a short amount of time.
Joel, this is one of my favorite topics to talk about with Blue Origin is going to be that New Shepard astronaut experience, because New Shepard has paved the way for a future of access to space. I mean, it's something just incredible to fathom the fact that you can go online right now and enter a web form on our website to begin your journey to explore and investigate what it's going to be like. You can purchase a seat to space. So it's now, because of this New Shepard program, that everyday people can travel beyond this planet. Let's take a look at some of the ways that flying to space on New Shepard has impacted so many of our astronauts to date.
Oh, lovely.
Booster.
Is this wild?
Go.
Each person that goes up there.
Oh my golly! This is nuts! Ground. Go.
All of a sudden has a totally different perspective.
Wow, look at that view.
Captain off. Go.
Of this little place here.
New Shepard is go for launch.
This is heaven!
It's almost like an out-of-body experience.
New Shepard has cleared the tower.
This is a new era where people like a teacher from North Carolina gets to go to space.
Space has always been something I've wanted to do, but it's never been accessible until now.
Look at that view. Look at the view.
It's just unbelievable. You have to see it with your eyes to really take it in. Everybody else, good going.
To space! Look at the Earth! Just look outside! Look at the Earth!
This is a life-changing experience. Everybody needs to do this.
It's absolutely insane. I mean, it's the coolest thing ever.
Oh my word! I'm just spinning.
That was enlightenment.
It was the best experience of my life, by far. Everyone in the world deserves to see this. Everyone needs to see this. Oh my God.
It's just a dream come true. I wanted to do this my entire life.
I just went to space as the first woman from Mexico.
I think we need to give this gift of perspective to everybody.
Oh man, this is so cool. I always said I'm gonna do it, and I just did it. Into space!
What you have given me is the most profound experience I can imagine. I can't believe this.
As soon as you land, you will want more of it.
So you can really, you can see the impact that this experience has made on all of these great people. They all experience it in their own ways. They exit the crew capsule and they kind of just spill out their emotions in real time. And it's just really just incredible for us to be able to talk to so many of these people who get to do what we don't get to do, which is to see the effect of looking at your planet from outer space.
That's right. That's why I really think of our astronauts as the pioneers that they are. They are going and forging this path so that so many of us will be able to then be able to follow in their footsteps. So this is really what it's all about. As you know, even our name is Blue Origin, and I want to spell it out. Blue Origin, why we are named Blue Origin. It's because of Earth. It means planet Earth. Because when we are up in space looking down at planet Earth, you see it as this beautiful but yet fragile small blue marble. It's in fact why a blue marble is my good luck token that I always keep in my pocket for every launch. And so on New Shepard, astronauts get to witness this firsthand, our planet in the vastness of space. And when they return, they have a hope for future for our planet. It's incredible in the fact of the overview effect, how it can rewire almost your framework, your mindset, how you perceive yourself, how you perceive your purpose on this planet, and what you want to do to ensure that our future is a beautiful and safe one. So far, we've actually flown 43 people across 8 human flights, and one of them has actually flown twice.
That's incredible. All told, that's over 6% of all the people who have flown above the Kármán line have flown on New Shepard. So let's talk a little bit more about what's going on from here with New Shepard, the program. What's next?
Well, I'll tell you, the demand's going up. Every time we get this rocket to launch, it is something that, again, the interest goes up and up. So, there are only so many flights per year that we can do. There are only so many seats. So again, with that demand going up, it's just simply about ensuring that you secure your seat in a timely fashion and make sure that you're able to get above that Kármán line when and as soon as you are ready. So Blue's going to be able to support that by increasing our cadence and increasing our capacity to fly. But one thing we will never compromise is safety. So I really want to take a moment and talk about that. We like to talk about the redundant safety systems that we have all over New Shepard. There are backups to the backups, okay? The entire system has been designed around safety at the center.
Yeah, and that commitment to safety reflects our dedication to all of our astronauts and to everyone that is on the ground at Launch Site 1.
And I've talked to our astronauts many times over, different ones that we've had and even future manifested astronauts, and they talk about that safety gives them the assurance that they feel safe to come on our rocket, to look forward to their flight, and then they can really focus on that experience and again look down at beautiful planet Earth.
Yeah. So Isabella, you've been part of the astronaut sales team now for some time. Tell me, what are some of the things you hear from prospective astronauts? What are the things they look forward to with their flight?
Well, I'll tell you first things first. Astronaut sales, it's such a funny thing. You don't have to sell going to space. I mean, who wouldn't want to go, right? It's something to where, talking to these astronauts, the experience in and of itself, I'll tell you a bit about it. So what you could expect is to come out 3 days before your launch. So you're going to come out to the beautiful West Texas desert that you can see here as the landscape is right behind our rocket. You'll come on in and you'll get to see, as you have seen in some of our clips featuring our New Shepard vehicle, the beautiful Kármán line bar, our top-notch hospitality team that rolls out what I'd say is the blue carpet for you. And then you're going to start to get prepared for your flight. You'll get your hearing protection fitted. You'll go ahead and hop in that spacesuit of yours, your flight suit. And then you're going to start your astronaut training. You'll do 2 full days of astronaut training with some incredible CM7s, our crew member 7s. We can elaborate on that a little bit later. But again, you're going to go through 2 full days of astronaut training, and on that 3rd day, you get to fly to space.
That's so incredible to just think about the overarching experience that you get, not only of flying to space, but I think you and I both know, just having visited the West Texas desert, the Launch Site 1 facility itself, astronaut village. It's more than just a experience to space, but you really spend time bonding together with your fellow astronauts and kind of forming friendships that you're going to hold on to for the rest of your life.
You nailed it. You nailed it, Joel. Because, it is so much more than, believe it or not, going to space. I can't even believe I would say a sentence of, you're just going to space. Okay, no, it's the fact of there's an entire journey that our astronauts have that follows their flight. It's you're going to space, you're becoming an astronaut, but it's what you choose to do with it. Are you choosing to open up a door to perhaps representation for a home country? Are you opening that path for the next generation to inspire your children, to inspire, again, just the next generation of those that are engaged and invested and perhaps even following careers into the aerospace industry?
That's right. Well, as you can see, we're still in an extended hold here. You can tell by the top right-hand clock that's ticking away in the screen. Let's keep talking about this astronaut experience, though, because at the end of the day, this is what it's really all about for New Shepard and for the astronauts that sign up. Let's watch the little clip that we have prepared, which kind of digs into what that 4-day period is like once those astronauts come on site to launch Site 1.
One of my favorite videos, Joel. My gosh, Joel, that just gives me goosebumps every time. How about you?
I mean, I've been down there for other launches just to witness those astronauts experiencing what they're experiencing, and really, I love West Texas. I love going to the launch site. It's great to be able to see the rocket fly, but really just like interacting with these astronauts that are going through this experience is really the inspiring thing.
It just captures that raw emotion, and it's not just the emotion of our astronauts that are flying, it's their entire community that comes along with them. It's their family, their plus ones, again, their plus a few others that again get to follow their journey, have been encouraging them and following again about their dream coming true and being actualized courtesy of Blue Origin.
Yeah. So you've spent time down there with our astronauts. You've talked to so many of them. Isabella, tell us about what do they say, and what do you like to talk about most when it comes to remembering the time that you spent on site and preparing these astronauts to fly?
Yeah, I really like to follow the entire journey of an astronaut. So, before they fly, what is it that they're most looking forward to? And then kind of following up those types of questions when they come back to Earth. So, what were you most surprised by, or what were you expecting? And I like to collect this information and think of it as data and share that with our future manifested astronauts and share that with those that are hoping to be able to become an astronaut one day, and share with them what they've learned so that way they can prepare for their flight in that manner. It's really special to hear some of those, and in regards to what some of those astronauts have shared with me, that would be things in regards to go into this flight open-minded. You might have a concept of what to expect space to be like, but it's simply more than you can even wrap your mind around. The blackness of space is what we hear a lot of times, and the curvature of the Earth. It just brings people to tears when they come back in terms of looking again at this planet Earth, how beautiful it is, but also how fragile, and the importance of being able to protect it. The second thing I definitely want to mention, which is actually my number one thing, is talking to these astronauts about what's your why? What's your why? Why are you doing this? What is it that's pulling you? Because for you to want to go to space, again, you're going to be one of the first 1,000 people going to space. There's something that's pulling you inside of you to do this. This is something to where you want to be a pioneer for the future of space exploration. And so for many, again, it's being an explorer. It's going somewhere where others have never gone before. And again, giving sometimes representation to nations that otherwise might not have had if you will, an Apollo 11 moment. That's something that's really, really special. And for others, it's scientific research. We have the opportunity to have payloads on board. And so, of course, today we're looking at this beautiful rocket where we have 12 payloads on flight. And so that's just something to where everyone's journey is a little bit different. And we love to be able to bring someone's dream of going to space to life and really welcoming, if you will, that vision of theirs.
That's incredible. I love hearing you talk about the astronaut experience and the promise of what that experience does to people. It's pretty clear that you yourself are pretty passionate about it, so thank you.
You know what? It is something really special to be a part of. And so when we have 6 astronauts on board with a traditional New Shepard flight, again a human-tended flight, we would expect to have 6 astronauts on board. When they come to the West Texas desert, they talk about what their zero-G plan would look like, what they want that to be. Some choose actually to stay in their seat so they can prioritize looking out those giant, beautiful windows. Look at that on the top of the rocket, my gosh. And they stare out the window and they look at planet Earth again, and that's what they came to do. Otherwise, it's one to where some want to get unbuckled. They want to float around at 0G. And again, other ones, they might have research or a payload. They might, choose to take that time at 0G and really, again, incorporate it. So what I want to highlight, again, is the fact that there would be 6 astronauts on board. When we do that, we incorporate each individual's vision for what that's going to be like. But there's also the opportunity to buy a full capsule. So if you want to have a little bit more autonomy over what that inside experience can look like, that's something that we can certainly facilitate.
That's incredible. So many cool opportunities to work with you to potentially get on a future manifest and experience what so many others have been able to experience so far. So you can see here we're still in a hold. This hold's going a little bit longer, and we're going to let Mission Control keep working out those final kinks in the process before they clear that hold. We're actually going to take a little breather here and watch the rocket while we await the launch crew to wrap up these final preparations. Don't go anywhere. We're not going anywhere. We're going to be here for the journey, but we will share updates as soon as we have them. right, as you can see, we are still in a hold here as the mission control team in Texas is working final technical issues and trying to clear the hold. This is one of the longer ones, of course. This happens with the operation sometimes as we make sure all systems are completely go for launch. Safety is paramount, and they just want to make sure that the rocket, the vehicle, the operation, the ground crew, everything is good to go. So bear with us. We are talking to Mission Control here in the background, and we are getting as much intel as we can to share with you. So we will be back with you in a second. All right, everybody, thank you and welcome back. This is the NS-27 launch for New Shepard, and we are just hearing from Mission Controls. We're talking to them in the background here that the flight team has decided to terminate the countdown for today. That means we're going to scrub the launch for today. They're troubleshooting a vehicle issue that will basically take us outside our available launch window. So we were pushing up against the end of that launch window, and we've basically made the call to go ahead and scrub the launch. So always disappointing to get to this point, but I think we want to make sure all these systems are completely ready to go and be certain about the launch conditions for flight. So. We don't currently have any new launch window to announce, so please continue to follow Blue Origin on social media as we will be revealing the new launch window and the new launch attempt date as soon as we have it.
That's right, Joel. And I just think that this really speaks to Blue Origin and our overall assurance to fly when we are ready and ensure that we have a safe vehicle to fly.
So yeah, once that turnaround plan is confirmed, we'll go ahead and announce that new launch window. So follow us on social media for updates. Otherwise, thank you all for joining us today. We are happy to have you along the ride for the first attempt for NS-27, and we will see you all very soon.
Very soon.
All right. Gratitum for Rossiter.